My name is Kago the Innocent at Our Lady of Africa Mukono, Senior to Central. This is Okrut Jethro, King Finney, and Lubura Francis. Here before us we have a draft of an irrigation sprinkler. And here we see this is our garden. And this is the sprinkler made up of bottle top and straw. This is our powerhouse. It has even a switch, but it's powered using dry cells. This is our supply tank. And this is our reservoir. We know that agriculture is the backbone of Uganda, and we've realized that many of our parents out there need it to survive, but there is scarcity of water, most especially in areas like Karamoja and so on. But we see that since there's no water, they need a way of farming. So we have decided to come up with an irrigation plan. As you can see it, we are expected to see that the supply tank powered by the reservoir will receive water basing on Pascal's principle, and the water will flow to the sprinklers and it will go around the whatever. We shall see that the sprinkler has a straw and bottle top, but it is able to rotate around the garden using the help of a motor, and water is able to flow from here to here under pressure, because according to Pascal's principle we see that pressure in fluids increases with depth. That's why water is coming from the bottom of the reservoir to the supply tank. Here on our power bank, on our powerhouse, we see that there is a switch. In case water is coming, you switch on from here, and this is how it can be modified using, this is our switch, and this is our powerhouse. It can be modified maybe using electrical energy, solar energy, and maybe even any other. Here in our garden, I'm going to add some dry soil, and then we see how it may work, but I'm going to expect Jethro to be by the switch so that it turns it on. Francis, I expect you to please pour water in the tank. The soil is dry, and let us see how the sprinkler is going to help in maybe making this area wet and suitable for plants to grow, since agriculture is the main backbone of Uganda and it helps us so much, especially our parents who are farmers out there. As you can see, the more water is increasing, the pressure, it is coming in with more pressure, and it is continuously moving up the tube to the supply tank. When it reaches the supply tank, which is made up of a straw, bottle, and that, it will be able to come through the straw to the sprinkler, and Jethro will turn on, and we shall see the sprinkler turning around. Since the outlet of this water from the reservoir is at the bottom, it is at the bottom because we need a lot of pressure for it to reach the supply tank, and the pressure is supported by Pascal's principle. Now, as you see, water has reached the sprinkler. Jethro is going to switch on the powerhouse. It powers the sprinkler and the straw on the sprinkler enables the water to circulate around. But here we see that it is not spreading throughout. Why? Maybe energy. You can modify this by maybe using more dry cells or electrical energy. This is a major, this can help us to mitigate some of the problems of our parents there who are farmers and they are in scarcity of water, they are in drought areas like Karamoja. It can help us in that maybe, and they can, if there is no rain, they can pump water from underground and it is able to come into the reservoir, and the water in the reservoir is pumped to the supply tank, which takes it to the sprinkler and keeps on wetting the soil, making it suitable for crop growing. Here, this project has enabled us to at least reduce on the pollutants in the environment, because bottles themselves are pollutants in the environment. But if we're able to come up with such, it helps us to mitigate the problems of pollution in the area.
My name is Jethro Kut Shepherd at Our Lady of Africa SS Mukono, Senior 2 Central. Just to top up on what he said, this setup involves an integration of different subjects. For example, agriculture, where we have used soil, then geography, where we have used, this is an irrigation scheme, then also in physics, where we have applied Pascal's law that pressure increases with depth in fluids. Then also the powerhouse, which involves the use of chemical energy stored in batteries.
In addition to my friend's explanation, I'd like to add on and say that this scheme is really important and helpful in our society today. Remember, there are very many areas that are there that are really dry and cannot have this kind of rain that we experience. For example, areas such as Karamoja, they are really dry generally. If we encourage this scheme, it is going to help very many people in society. And in addition, it's also going to help on plastic pollution, because almost 70% of our environment is filled with plastics. They are overwhelming, and so as we thought of it wise to use these plastics in order to solve the problem of pollution. Ladies and gentlemen, this setup, as you've seen it generally, it is going to be very, very helpful. And in case someone would like to take it up on a large scale, it is going to be beneficial. I would estimate it about maybe like 7 to 10 million to take it in a real sense, depending on the size of land that you have. This tank can be modified into a real tank. For example, the other 1,000 liters etc. above and among others. And then this supply tank can be used a smaller version or a smaller tank, right? This was representing a pipe, right? This pipe can be bigger, and this one may be smaller. This motor, you could use motors that take higher voltage, among others. So this here is our power source, our powerhouse. You can make it some sort of generator. You can use generator in case you don't. You can use fuel as a generator, as your source of energy, or you can use solar energy, depending or accordingly. A switch, you can switch on and you just be calm. You go in your house and relax as the garden is being watered. You don't need to stress much. You just switch it on, go and relax, do your other things. You come back and switch it off.
My name is Lubura Francis, a student of Our Lady of Africa, SS Mukono, and I'm a senior 2 student. So to supplement on our friends, as they have already made an experimental draft, you can call it a draft, we can, now someone out there may ask a question, how can I put this in reality? So here, instead of using this, you may use underground water, advantage of underground water, or you may use any water source such as a lake, a pond. Maybe you may dig up your own pond. So, in order to get the water to pump it to the tank, you may need an actual electric pump. Maybe these pumps that use thermoelectricity, that use these fossil fuels. So you can pump it out from the lake or the pond, and then you connect it. Here you may use a real tank. I think all of you know the plastic tanks, the real tanks, and here you may use a real pipe. So this, you may need an actual sprinkler, or you modify the size of the pump, of the size of the motor, the size of the motor, it must be big. And here, we need to use either this hydroelectricity or solar energy. So solar energy may be better in a way that it ensures constant supply of energy to to our system. It ensures constant supply of electricity to our system. As in, maybe if hydroelectricity is off, solar energy can prevail. Now, since we are new curriculum students, our new curriculum is called the competence-based curriculum. It deals with problems in the environment and how we can solve them. So, this system can solve maybe a problem of pollution, because what we have used here, we have recycled this, and so they will mitigate the problem of pollution in the environment. And even the way Michaels have already talked about it, scarcity of water in different areas in this Uganda. Thank you.